Hello, everybody, and welcome. Thanks for joining this Twitch session. This will be the first of many office hours that we're actually going to be doing here at AWS. We're going to be covering topics from the container space, including EKS, Fargate, Kubernetes itself, ECR, and then we're going to be diving into the serverless space as well. I am Chris Hine. I'm a developer advocate here at AWS, as well as a CNCF ambassador, and I'm joined here with Bob Wise and Mike Groot. Would you like to introduce yourself, Bob?
Sure. Hi, I'm Bob Wise. I'm the GM for EKS and also responsible for the open source contribution work that we do here on Kubernetes.
Fantastic. Thank you for joining us. And Mike?
I'm Mike Groot. I'm a open source software engineer on the EKS team. I'm also a Kubernetes upstream maintainer for a lot of the AWS integration there. And I work in the community.
Fantastic. So to kick this off, we're going to be really talking about open source and Amazon EKS. So what we're doing in that space, how we're contributing back, and asking or answering questions for you. If you have them, please put those in the chat. So to get this started, can you talk to everybody about our approach towards open source on the EKS team?
I will do that. I think the place we have to start is with our commitment to running upstream Kubernetes as part of the EKS service. So we often talk about running a conformance service, which means that we can pass the conformance tests. Mm-hmm. But the conformance tests in Kubernetes just test the APIs, and although the coverage there is improving over time, it isn't comprehensive enough to test every line of code. So in order to run an upstream project or upstream service like we do, we feel that we have to be involved in the community, helping fix problems, contribute, and be part of that community in order to stay upstream. So yeah, that's our approach to it. Overall, it's a really important part of the product. Within the team, we think it's important for everybody on the team to be involved and engaged in open source. Now, of course, we have different roles on our team, which is, by the way, expanding. Quick hiring note there. And so we're doing a lot of hiring in the open source area specifically, but we try not to have people on the team that are dedicated and separated onto open source or dedicated and separated onto running the service, but to try to have a more integrated approach where everybody does. Like some people might do more, like Mike, but and some people might do less, but we really want the entire team to be involved in the upstream contribution.
That's fantastic. So everybody's working together on the whole service. It doesn't matter if it's open source or not, but everybody's pushing it forward.
Right.
That's fantastic. So Mike, can you talk to us about some of the projects that we're actually working on in the open source world?
Sure. We've actually kind of got a lot of them right now. I guess I could go through a list of them, but some of the more interesting ones are the IAM Authenticator and CNI. These are two really kind of integral plugins to make EKS work well and integrate well with AWS. Mm-hmm. They're both open source projects. They're projects that AWS started to they're projects that AWS started to kind of help to better integrate Kubernetes. We've just done a new release of the IAM Authenticator, the 0.4.0 release. Okay. It bakes in a whole bunch of new bug fixes and adds some additional caching and some cleanup to help people stay under API rate limits and be able to work better with that. And the CNI is something we've also just done a new release of. Uh-huh. The 1.4 release has a bunch of new stability fixes in it. Uh-huh. It's also the first release we have available for our ARM platform.
Oh, fantastic.
So that's also something we've got a public beta of that's available on our containers.
So for everybody that doesn't know, what is CNI?
CNI is the Container Network Interface plugin for AWS VPC. It's the component that allows you to integrate with the underlying VPC networking. So when you launch pods in your Kubernetes cluster, it'll acquire a real VPC IP address and it'll hook it into kind of all the networking that you're used to in your AWS account.
Oh, wow. Okay, so when you're running in AWS and you work with our CNI plugin, it gives a very flat networking structure? It's not like an overlay network like I've heard from other providers?
No, it's natively integrated into VPC, so you can hit your containers with a normal VPC subnet address that you've already assigned. There's no additional overlays necessary. It'll handle acquiring new ENIs and kind of packing IP addresses onto an instance so that you've always got IP addresses available.
Okay.
Yeah, it's completely integrated into AWS networking.
That is very cool. And so you were talking about the AWS IAM Authenticator. So what is that project? What does that actually do? How do customers use that?
So the IAM Authenticator is a component that allows you to use AWS IAM to authenticate against your Kubernetes cluster.
Okay.
It uses some publicly available but kind of lesser known IAM APIs to actually generate auth tokens that the server can validate, and it allows you to control all of your access control policies on the within IAM, but still give you the native Kubernetes experience.
Okay.
It can be used as a plugin for kubectl as well. So all you have to do is have AWS credentials available on your laptop or on your EC2 instance, and you're ready to go.
Okay. So it basically sits, I'm guessing, in the control plane and basically accepts requests that the API server sends it, validates that, passes it back through, and says that you're allowed or not.
Yep.
Does it handle any of the, like AWS is known for our IAM structure, does it handle any of the authorization or anything like that, or is it strictly authentication?
It's strictly authentication.
Okay.
Kubernetes RBAC and access control within Kubernetes does kind of that next level of authorization on top of your
great.
authentication.
So anybody that's used to working with Kubernetes can use those things that they're already used to. The same role-based access control that they use for their service accounts also works for the authenticator as well?
Yeah, and it tries to strike a good balance between kind of native AWS integration, but also native Kubernetes integration. So if you're comfortable with either one of those, you should be able to kind of pull them together in a way that works pretty natively.
That's really cool. Okay, so 2 new releases that just came out. What other projects do we have out in this space?
Well, so those are kind of AWS integration specific. Let's kind of take a look at what we're doing in the community.
Okay.
One of the big things we've been doing is working on our CSI driver integration.
Okay.
So CSI is the container storage interface.
Okay.
It is a standardized way for Kubernetes to reason about storage. So NFS, block devices, things like that. We have 3 flavors of our CSI driver, one for EBS, one for FSX, and one for EFS.
Okay.
So it depends on what type of workload you're running as to where you would use those. A lot of people are probably familiar with EBS. So the CSI driver for EBS handles things like attaching EBS volumes to your AWS instances and making those available to the pods running on those instances.
Okay.
Whereas EFS is more of so EBS is a single attach solution. So you can attach a block device to a single instance, and only that instance can read and write that device at any point in time. For customers who have kind of bigger workloads that need shared read-write storage, EFS is a good solution for that. It looks like NFS, but you don't have to manage the storage. And our CSI EFS driver handles kind of attaching those to your instances, making them available to your pods, similar to what the EBS integration does.
Very cool. Very cool.
So we've just got new releases of those out as well. They're currently in beta upstream. We're kind of going through the process with the community of removing some of the cloud integration that is in Kubernetes and moving them to kind of more standard plugin interfaces. This has been a project that's been going on for, I believe, about 2 years now within Kubernetes, trying to remove cloud provider specific code from the Kubernetes core tree and put them behind well-specified pluggable interfaces. The cloud provider SIG is one of the special interest groups in the Kubernetes community that's driving a lot of that.
Okay.
And we're working with them to move that program along as well.
So Bob, you've been around the Kubernetes community for a good amount of time now. So can you talk about how like SIGs work? Kind of explain. You called it out as special interest groups. Explain kind of what that is and why the community's done that.
Right. Yeah. Let me get to that. I think that Kubernetes has gotten so big and is moving so fast, and so many customers, so many companies depend on it as a core part of their infrastructure, that ensuring that the project is able to both sustain growth, but also keep quality and performance, and those kinds of operational benefits is really important. And one of the ways to do that is to try to constrain the core project. And one of the keys to constraining the core project is to move to this plugin model. And so, for example, in the cloud provider space, there's cloud provider specific things. But even if you start looking at alternate storage mechanisms or alternate networking mechanisms, or even if you look at, for example, alternate runtime. So the idea behind something like CRI is to see that there's a standard interface so that we can constrain the core project to being like a kernel of really solid stuff and then extend it in various ways. One of the effects of that is that the more of the code that you need to actually run a Kubernetes system is actually moving outside of the Kubernetes environment. So maybe some will move in, some will move out. I think we're always willing to contribute our code upstream. Community generally has been moving a bit away from that model, trying to like push some of the code out. So what you'll see from us is some of this plugin code will go into AWS Labs repositories, but that's how the community is evolving. In other cases, there's code that may start in those repos and move in. By the way, I did want to make a shout out to the Heptio folks who actually used this model to start originally the AWS authenticator was the Heptio authenticator, and they contributed that into the project, and we worked with them on that. So, much appreciation to them for getting going on that back at some point.
Yeah,
a very nice space to build off
yeah,
of.
exactly. So
I think it was about a year ago, if I remember right.
So one of the other mechanisms to try to manage scale and growth is SIGs. Like how do you, and this is a typical organizational problem, how do you break teams apart in such a way that they have enough autonomy to make progress and make good decisions and make progress, and yet still try to keep everybody, all of the cats in the herd, at least kind of generally running in the same direction. And so SIGs are a key part of that. There are a number of SIGs that are kind of cross-cutting. So like a good examples of the cross-cutting SIGs are things like the testing SIG, where we have a lot of interest. Scalability SIG, which I'll maybe talk about in a minute. The API machinery SIG is one that, like the core to running a Kubernetes system is that API. So that's one of the places where all the cats are kept together in a corral. And of course, there's the steering committee as well. But the steering committee is more of a kind of overall governance management group. So a key thing for a team like ours that's engaging is trying to figure out like where and what SIGs are we going to spend the most time in. So clearly the cloud provider is a really important one. But SIG scalability, we want to be able to make sure that we can run large clusters, that we're able to support customers running really big clusters. So, and this has been a personal interest for a long time. So way back in the day, the very first SIG, they weren't even called SIGs those time. The very first SIG formed in Kubernetes was the scalability SIG. Joe Bate and I started it off. And I don't even remember what we called it in those days, but it's what became a SIG. Also, fun fact, that was the first official group inside the Kubernetes project to use Slack.
Oh, wow.
And they were definitely folks who thought that, let's just say, a lot of folks who like IRC were not that happy with Joe and I when we decided to move in that direction. But that's the way the community works today. So.
Yeah.
So that's fun. So I was one of the co-chairs for SIG Scalability for a number of years. I've now handed that off to one of the folks on the EKS team, Sham, who's been involved in that for a long time. He gives a great talk at KubeCon. By the way, a bunch of us will be at KubeCon. Make sure you look us up if you're there. If you see us wandering around, come up and say hi.
Absolutely.
Sham's KubeCon talk on scalability is amazing, and I think we're planning on having him in a future office hours session
I think so. We'll see.
We should put him. We should put him on the spot. Like, ask Sham your scalability questions.
Yeah.
Yeah, he's awesome.
That would be great. Yeah, we will definitely try and get that in there.
I'll have to make sure I let him know when we get back.
That we're signing up for
I've
this.
just put him on the spot. But
Perfect.
Yeah, he's terrific.
Well, that's good. So now, where can people go to find information on this kind of structure? Because it sounds like there's a lot going on there. Is there like repositories that you know of that people can go to?
So I think if you just go to Kubernetes.io, I think all of the SIGs are listed there.
Okay.
There's a list of all of the SIG meetings. So Kubernetes as a project is very dedicated to openness and transparency. So the SIG meetings are all the schedules are announced. They're held in the open.
Yeah.
So
And if you
Zoom
missed
meetings.
previous ones, you can see them on YouTube.
There's recordings are made and posted, so it is very open community.
It's amazing.
Yeah.
Such a cool. Yeah. I think the repository where I've seen most of this is, and like getting started guides and stuff like that, is the Kubernetes community repository as well.
Community is a great starting place.
Yeah, it's a good starting place. If you're interested in getting involved, like go check out those repositories and see what's going on there.
There's a weekly meeting, which is the main community meeting, and that's a great place to.
That just happened today, didn't it?
Yeah,
like
it did.
About an hour or so ago.
Right. So if you want to start getting your fingers on the pulse of kind of how that community works, that's also a great place to start. There's usually demos and other things that happen there, so it's a good meeting.
Yeah, there's updates on SIGs as well. If you
Correct.
want to get more involved in a specific SIG, it's a great way to kind of get an overview of that as well.
And we're all there, and you can talk to us. So in terms of what we're doing from an AWS perspective, some of the things that we've started doing are pretty new for AWS. So we have a containers roadmap that's public on GitHub. Can you talk about that?
Oh, this is great. This is one of my favorite projects. One of the other DAs, Abby Fuller, this was her mission to get this into the open. We really are trying to be more open and transparent, especially around an open source project where so much of the direction of the project is in public as part of roadmaps and SIGs and all that. It might be a little work to go figure it all out, but it's all there in the open. We really wanted to do be more open about what our plans were with regards to that as well. So I don't know if you can post the link.
I think we can. Here, I'll put that link in there for everybody.
That might be a good thing to do. So we really are welcoming people to take a look at that. Open issues, pull requests are welcome. This is our way to try to explain kind of where we're headed with a bunch of these projects. We don't do dates. This is really important for people to understand. Our priorities when it comes to running the service side are security and operation stability. If there is either of those two things, we stop working on features and we go and worry about security and operation. That's true for any service teams at AWS. So we always want to make sure that we're not putting ourselves in a box where we've said, oh, like this feature is the most important thing, when for us that's never the most important thing.
Makes sense. And I've seen that we're also doing things like we're kind of doing another new thing for AWS is just like previews. We're actually kind of being more open about some of the stuff that we're working on and where we're going. I think there's 2 running right now. You worked heavily on one of them, and then we have another. If you want to talk about ARM support.
Sure. Yeah. At reInvent last year, AWS released ARM instance support. It's kind of the same processor that you'd run in that you'd see in a cell phone or something like that, but at kind of a much larger scale. And we want to enable our customers to be able to use those for their workloads on top of EKS. So we've got a new Amazon Machine Image, AMI, if you will, that supports ARM and supports EKS. It's available right now as a public beta.
Okay.
We want anybody who's interested in ARM to go take a look at it. You can find it on the containers roadmap on GitHub. There's a whole set of documentation there as well. And if anybody kind of runs into any problems or would like to kind of see some changes there, open a GitHub issue, and we're definitely kind of keeping an eye on that.
Fantastic. So it's a way that everybody can actually start working with what we're building instead of just kind of having us just push it out there and be like, here's now this thing that we don't know exactly how you're going to want to use this, and we can get feedback before fully releasing it.
Right.
It's really cool.
We're also in preview for Windows support as well, which is
Interesting. Yeah, those Windows Windows containers.
Windows support is going GA. GA is part of 114, Kubernetes 114. So we're headed towards that.
Headed towards that. Okay, cool. And so we're on currently 1.12. So we'll get there. We'll get there soon. Hopefully.
We will. 113's coming soon.
Great.
Real soon now. No hard date. Security and operations first.
Security and operations first. Okay, great. So within the community as well, we have other organizations that are working with us, namely Weaveworks. We've done a lot of work with them. Right. Bob, do you want to talk about that relationship and what we're doing with Weaveworks?
Yeah. So in a similar way to what Heptio did back when, saw a need among users to build this thing, and so they built it as an open source project, and then we joined that effort, said, wow, that's a great thing. We'll work together with people in the community to build kind of additional things around Kubernetes on AWS. The Weaveworks folks did a very similar thing. They started this thing. Okay, so I'm a control guy, not a cuddle guy.
This is going to be a controversy right now. If you see CTL in the community,
it's kube control, not kube cuddle.
Or
just
kube
saying.
Cuddle, depending on who you talk to.
So EKS control is a command line system for EKS. And when we first started seeing it, we thought, like, wow, that's great. Rather than try to build something else, we should just join with them and work on it. And so they've done an amazing job. Frequent releases on that. So yeah, we consider when it comes to managing Kubernetes clusters on or EKS clusters, we consider there to be kind of three first-class citizens.
Okay.
CloudFormation, of course, Terraform, and EKS control.
Fantastic. I like
and
to hear that.
we have some. I think there's been. I think because our documentation hasn't been entirely clear on this, there's been a little bit of a confusion about like how dedicated we are to EKS control as a piece of software, and we're very committed to it. And we're working on some documentation updates to make it clear to everyone that it's a real thing for us.
Okay. That's fantastic. And they're also big advocates for GitOps. I know Alexis has been pushing that for a couple of years now. And can you talk about what that is and what are our thought processes around GitOps in general?
Right. I'm a huge GitOps fan. Whenever customers ask me for recommendations, and they don't all, right? Like there's not one good way to do things. But for those who are interested in what our recommendations are, we very much recommend a GitOps style of approach, which isn't to say there's a tool you should use, but it's more of a set of kind of practice and philosophically, how should you think about managing applications and managing clusters. And the GitOps thinking is that any change to a cluster, as well as any change to an application that might be running on that cluster, should go through a path of declarative intent. I want the thing to look like this. And then appropriate human review. So for code changes in like an open source project, it's considered to be best practice to have more than one pair of eyes actually look at something, and to ensure that you have the right set of eyes look at it. And using a pull request kind of method to, let me make sure someone else has reviewed this before we merge it. But once you've merged it, then it's done. Like, it's out there. And to have your tooling react to a request for a new state for your cluster, your application deployment to be done in that method is, I guess I wouldn't say the best practice, but definitely a best practice. And GitOps kind of encapsulates that way of thinking. I would say that there is a second important thing here, which is to think about pipelines that accommodate both cluster changes and application changes. So for example, you're going to move from Kubernetes 111 to 112 to 113. As just as an example, you should have your pipelines should determine whether should pass a test case before that deployment happens. So you really need to have pipelines that test the applications and test the cluster and meet in the middle and use that same kind of philosophy all the way through.
That sounds amazing. So there's a question from the chat actually that brings up. Someone wants to know, what are our views, and how do we work with the more AWS native services as well? Not divulging a little bit from the open source here, but
Right.
like how do we work with code deploy and things like that to kind of implement some of these strategies?
So one of the main missions for the EKS team is to, I won't say build, but help build all of these integrations between Kubernetes running on AWS, done by EKS, and all these other systems. Actually, most of the work that we do is not EKS specific in this regard. If you're running self-hosted or you're running on EKS, you'll get the benefit of a lot of the work that we do. And so if you look at
open source right there.
Yeah, exactly.
It's so fantastic.
If you if you think about like CSI driver work is about how do we integrate with EBS and EFS. But if you go across the kind of wide sweep of Amazon systems, there's a lot of systems. And so what we do is we work with a lot of those teams. So for example, the Kubernetes integration that's done and code deploy is actually the responsibility of that team, and we help them do that. One of the things I think is really important for customers to understand is that if for some reason they feel like one of those integrations is not what they want, if it's not serving their needs, they need to we'll help them with that. They should figure out how to contact us, use their account team, talk to the code deploy team, talk to us, and we'll figure out how to improve that integration. And this is the kind of work we do all the time. Good example: if you go into the open source roadmap, you'll see talk about our improving in IAM integration using the projected service token feature that's coming up in Kubernetes as well. So this is a motion that this is our lives is working on all these kinds of integrations.
So can people, if they're interested in those kind of those integrations, can people file issues on the containers roadmap as well for that?
Yes, absolutely. That's a really great mechanism.
Fantastic, cool. I know I posted an issue not that long ago, kind of requesting feedback both from the community as well about how to actually use or where we were going to go with maybe CloudFormation and how we could support more things besides just deploying clusters, maybe deploying resources from CloudFormation as well.
So in addition to the CodeStar suite of tools, it's also worth it for folks to take a look at CDK as well. That's yet another system that we're working on.
And what is CDK?
The Cloud Developer Kit.
Okay.
Development Kit.
I think it's development.
I think it's development kit. This is just one of the many teams at AWS that's figuring out how to solve these kinds of problems when it comes to configuration management, infrastructure as code, code deployment as code.
Very cool.
Yeah.
Okay, so what other projects are we working on? What are some other things that we're doing out in the open source world?
Well, one of the things we're really interested in right now and really excited about are our customers who are running ML workloads on top of EKS.
Okay.
We've started getting more involved in Kubeflow as well as some of the autoscalers. We're particularly interested in the Escalator autoscaler, which is a batch optimized autoscaler built by Atlassian. They have kind of set out to make something that I think originally was designed to run CI jobs, but it turns out that with a little bit of tuning, it's actually really well suited for large-scale ML training jobs. So we've got some active work going on there, and we plan to kind of continue to put some more work into that as well.
And who owns the Escalator project? Where?
It was originally developed by Atlassian, and they're the current maintainers of it. So we're contributing alongside of the Atlassian engineers. And
more integrations with other companies. That's
Exactly.
fantastic. I love that.
I think
that's the power of open source right there.
I think that is one of the great advantages of us contributing to open source in this way is it lets us work with partners, but it also lets us work with customers. And it's pretty amazing. In no other way can one of our customers actually write code that we then take and run on their behalf and manage it on their behalf. And this is one of the ways we can do that.
So can you talk about the differences? Because I know that there's the cluster autoscaler, which is what customers typically maybe immediately find because it's a Kubernetes-based project.
Yeah.
So how does it differ? Where would you go if you were to say I'm running a cluster of microservices? How do I pick and choose between these?
So Cluster Autoscaler it's a Kubernetes project. It's within the Kubernetes org, and it's the older of the two code bases.
Okay.
It's a very feature-rich autoscaler. There's a lot of functionality in there. But it was primarily designed for bursty workloads and things like shared nothing web apps and basically applications that are preemptible in a lot of ways. And you can tune around this. There's quite a lot of knobs in the cluster autoscaler you can mess with to do different things.
Okay.
Whereas Escalator was kind of a complete rethinking of how you do autoscaling within a cluster, specifically designed for non-preemptible jobs. And like I said, I believe it was CI workloads that they started out thinking about. And it's kind of grown into just more of a batch job autoscaler. It's a little bit better tuned for that.
Oh, cool.
You can use either to do either class of workload, but they kind of split up like that as far as how they're optimized.
Interesting. Okay.
There's I would want to make sure that no one is believing that we're not going to support the cluster autoscaler.
That's a good point.
We have we're intending on increasing our contribution level around that specifically. If you go onto GitHub, you'll see there's been a lot of customer requests around improved spot integration and some really great ideas. I also wanted to give a shout out to the Zalando folks who've done a lot of cluster autoscaler work here lately, and it seems like they've got some great stuff that they're working on in the space as well.
Yeah, they have a fork of it. They have a bunch of new stuff that I think they started to add in some of that spot work in there.
Right.
Looks pretty cool.
So that's definitely a project we're tracking with a lot of interest right now too.
Cool, and I think we have some commits in there for adding GPU support, if I remember right, into cluster autoscaler. So yeah, definitely some good stuff.
Yeah, we're
there.
definitely actively working on both projects.
Cool.
And we see a lot of potential in both of them.
Yeah, parallel paths. That's
Yeah,
fantastic.
exactly.
So now that covers. So in terms of like auto scaling, there's more than just cluster auto scaling that goes into a Kubernetes cluster, right? You have that's just the physical host. So what do we do? What are we doing in that space around? Like, is there other auto scalers that people should know about? For example, like pod auto scaling. Is that what can we do there?
Yeah, I think the way to think about this is that this is another one of those practice questions that I get asked a lot by customers, and it's really should we run an application per cluster? Should we run fewer, bigger clusters? Should we run more smaller clusters? And again, there's no right answer here, and a lot of these are trade-offs that you make based on your specific kind of interests and requirements. But if you've decided to make a set of trade-offs that are more around shared resource utilization, then you're going to tend towards running fewer, bigger clusters and putting more stuff into it.
Okay.
And so in that kind of deployment scenario, you end up with two scaling knobs. You need a scaling knob for a particular, I won't say microservice, service or some part of the application. Another topic perhaps to talk about, services versus microservices at some point. But at any rate, so you really want within that cluster, you really want to have scaling happen. And that would be the horizontal pod autoscaler would be the typical thing that people use for that. You don't have to use that. It's like you could build your own scaler in on top of that. There's also a newer vertical autoscaler, which is more about scale up rather than scale out, or scale up and down and scale up. So if you're running in that kind of environment, what you really want to have is a big knob for the cluster. So generally, when you're running in that kind of environment, you think about your overall cluster utilization. And the cluster autoscalers are generally oriented towards how is it that I have the big knob and make sure that my entire cluster is running at enough scale to manage all of the different teams or applications that are running within the cluster. So it's kind of a two-part. Think of it as two parts. Now, you don't have to do things that way. You can run a single cluster per application, and then essentially those two things just work together.
Okay. And what if you had like a mixed use cluster? Could you run all three of them at the same time? Like pods for scaling out the services, and then cluster autoscaler wrapped around those, and then you're maybe running machine learning jobs as well in that same cluster to kind of co-locate everything? Can you run Escalator as well with it?
Yeah, both Escalator and cluster autoscaler will run together in a cluster.
Okay.
The important thing to understand is they both manage autoscaling groups,
Okay.
the EC2 concept of autoscaling groups.
Cool.
So you don't want to overlap them in the same autoscaling group, or you'll end up kind of fighting back and forth. But as long as you can separate those things out into two different kind of sets of nodes, yeah, they'll both work together.
Cool. Fully elastic clusters for whatever you want to run in them.
Exactly.
How cool. All right. So at reInvent last year, we released AppMesh. What are we doing around there?
I'm glad you mentioned that specifically around the alpha channel idea. So AppMesh is one of the first teams that's doing that within container services. So that's definitely something to keep an eye on for the listeners. AppMesh is a service mesh. So especially when you start running larger numbers of services and you really want to start to have policy control and manage all of the connections between I would say, if you're making a journey, especially if you're making a journey from services to microservices, as the number of services grows, the management complexity around that starts to get very high, and you need some additional help.
Okay.
This is today the typical implementation of this is done with something like a sidecar injection. Typically, like Envoy has been the most popular choice for this. AppMesh is a Envoy control plane.
Okay.
So you use Envoy in order to manage the underlying mesh. This is pretty early for us. So we're really excited about this. This is clearly an important set of tooling. I do think that we review this as less like, in the long run, less like Envoy management and a little bit more like what do applications need when they need to do networking with each other.
Gotcha. Like application-aware
networking is kind of the long-term thinking here.
And we
Okay.
have released an AppMesh controller as well.
Yeah.
That's from the EKS team as well?
That is from the EKS team, yeah.
Cool. And that integrates into EKS and Kubernetes itself? Could you run that anywhere?
I'm not sure about that,
Okay.
but it does definitely integrate with EKS.
Okay.
You can probably run it on AWS as well, but I'm not sure as sure about that. But we've also got Cloud Map integration planned in the near term as well, which is another service we released at reInvent last year. It allows you to do service discovery within your clusters.
Oh, cool.
And it should transparently kind of integrate into the AppMesh controller and allow your containers to find each other.
Very cool.
Let me add some comments about AppMesh, because although this is a Kubernetes-centric discussion here today, one of the main advantages to AppMesh is that it isn't a Kubernetes-only system. We have a lot of our customers use EKS, and they do self-hosted Kubernetes, and they use EC2, and they use ECS, or they use ECS and Fargate. And so, like, one of the main design points for AppMesh is to ensure that you can build service meshes across anything you're running on AWS, not just EKS. So I think that's a really significant
point, yeah.
advantage.
Yeah, it really brings everything together. You could run it anywhere. Your operations team, if they didn't want to run Kubernetes, they wanted to do Fargate or ECS, they could run it there, but then other teams internally could, and everything kind of all works together and meshes together. I think there was a really cool demo from at the Santa Clara Summit that Nick Colt did about mapping together Kubernetes and Fargate. Really cool stuff that's going on there.
Yeah.
And so our controller, what does that actually do? How does that work under the hood?
That's a good question, but
Okay.
I don't have a good answer for it.
All right.
I think
It
this is
injects the Envoy sidecar for you, if I recall correctly. It basically just sits there as like an admission controller, injects the sidecar, and reconfigures it. And then I think, if I recall correctly, it has a couple CRDs in there, or custom resource definitions, that allow you to actually configure your whole mesh from from Kubernetes, which is a really interesting concept. Do you want to talk about CRDs?
No, I was going to say you should talk about CRDs.
I thought you were going to point that back at me, because there was also a question in the chat about this.
AWS operators?
Well, AWS operators, the question actually was, do we have any operators or operator projects related to EKS? So I actually maintain a project called the AWS Service Operator. The concept behind operators in general, if you're not familiar, it was a term coined by CoreOS a few years back. And it's really, it centers around being able to integrate and run a control loop within Kubernetes that manages custom resource definitions, and that's a primitive of Kubernetes that's a newer addition. It's kind of been an evolved thing that came from TPRs, which were third-party resources, and an extension of aggregate API servers, all components of Kubernetes that have led us down to this place that allows you to extend Kubernetes to almost manage anything you want with it. Which is something that makes me so excited, because I love the thought process of being able to manage anything from Kubernetes itself.
And we get like a lot of our users ask us for that, especially when it comes to those integrations across AWS. They really prefer a more Kubernetes kind of native way of doing that. And so this is one of the ways to do that. A lot of other customers are happy to do it the more AWS native way, perhaps. And so we really are dedicated to trying to support kind of both working models.
Yeah. No, it's great. Yeah, like with the operator, you can deploy a DynamoDB resource directly from your YAML files, for example. So,
Exactly.
that sounds great. So there's a big issue that has been on the containers roadmap for a long time, or for a while, that we get asked about a lot. The IAM to pod strategy. What are we doing there?
Well, that's something that we've been working on publicly. If you look at the containers roadmap, you can see kind of some of the designs we've done there.
For everybody on Twitch, it's issue 23 on the containers roadmap. I have memorized that because I like to track where it's going, because it's a very interesting thing.
And it's something we're really excited about, too. I think at this point we consider ourselves to be design complete on that, and we've begun work on it internally as well.
Okay.
It's something we're ultimately going to open source once we kind of get a little bit further down that track. And what I've heard is that we're shooting for kind of late summer, early fall as when that's going to be something that we can show to our customers.
Cool. And that's using, you had mentioned this earlier,
The projected service token.
Projected service tokens.
Yeah, I think this is if you're trying to interface Kubernetes to other kinds of systems, this is a standard. Think of this as another one of those standard extension mechanisms. How are we not going to do a special thing for every one of these different systems, but have a standard way to do it? So Kubernetes has a standard way to do it, which is the projected service token, and we're going to work with that extension point to make this work with IAM.
Very cool. And so that'll basically give out AWS credentials so that a pod could actually use those instead of using the instance metadata store?
That's correct.
Very cool. Okay, so we could actually pare down the permissions that an instance has to have to bare minimum.
And it's that's a really important kind of least permissions philosophy there that we really want to support. And it'll let people run their clusters more efficiently because they won't have to keep certain workloads off a node if it has too many permissions. For
Gotcha.
example.
How do customers solve this today?
They do mostly that. They keep
using anti-affinity and
yeah,
affinity and all that
exactly
stuff?
taints and tolerations
Gotcha.
and so forth.
Okay, very cool. So what about, you're running these microservices in your cluster. What are we doing about how to get traffic into them? What kind of tools are we building in that space? Like ingress, for example.
So we're working with the community on an ALB ingress controller.
Okay.
So the idea of ingress is once you create a deployment on your cluster, you can create an ingress object that allows traffic into the cluster by some means. So popular ways of doing this are Nginx and the traffic. There's a couple of them out there. But the ALB ingress controller tries to integrate really well with kind of AWS native ALB functionality. We've got it out there. It's released in public, and we consider it GA at this point, but we're kind of continually adding features and working with the community on that. We've done some cool things around trying to make that more efficient. Things like the IP mode support, which will allow ALB to send traffic directly to pods as opposed to just instances, and more efficiently route your traffic within the cluster.
Oh, wow. So does that mean that it could skip kube proxy, for example, and just go directly to our ENIs in EKS? That's really cool. Okay.
Yeah, which should help a lot for customers who don't want to route traffic horizontally through their cluster, or just really want the most efficient path for
that's really cool.
Incoming traffic.
Okay.
There's a lot of work going on there too. We put a lot of work into TLS and integration with ACM, the Amazon Certificate Manager.
Cool.
So if you're managing all your certificates in ACM, we can auto-discover those based on the names you put on your ingress objects.
Oh, cool.
And just hook them right up to your ALB.
Really automating the whole system. I mean, that's one of the things that ever since I got into Kubernetes, like it made me so excited that it was so excited that we were just automating all of this stuff that everybody had to wire together manually before. It's really cool. Okay. Now, so around machine learning, what are we doing in this space? Bob, I'll let you take that.
This is so exciting. One of the things that was really amazing to see pretty shortly after we launched EKS was we started seeing a lot of machine learning workloads. We have really great EC2 instances, the P2 and the P3 family, that have lots of GPU horsepower on it. And it turns out that TensorFlow, Kubernetes, EKS, and the P3 instances are especially awesome for doing distributed training.
Okay.
So the sort of single biggest use case we see is customers running like really large, complicated models, and using some of the advantages of the overall AWS system. We have these amazing systems. S3 is like, if you have huge amounts of data that you need to process with ML algorithms, S3 is an awesome thing. But we also have some newer products like FSX Lustre, which is really ideal for this kind of use case. So we're
You
seeing
can wire those two together, can't you?
yeah,
So,
you
like,
can wire these two together. There's a blog post that just went out yesterday, I think, talking about maybe that's another link we can dig up. If I can.
Yeah. We can get
we
that
can
link
do
in
that.
the-
We
in
can
the
get that
chat.
link in there. That'd be great. To show like how do you wire all these things up. We have a project that is another open source project where we're trying to help customers wire all these things together and then test that collection of things that they've wired together for their use case. At the moment, it looks a little bit like a benchmarking kind of utility in the sense that we can take some standard ML benchmarks and show how you would use those benchmarks with these different kind of approaches wired together. But the goal there is to try to help customers figure out how to make these trade-offs. Again, it's like there's no right way to put these systems together. There's a better way for someone that might be, different for someone else.
So in that blog post, that talks about Lustre and Kubeflow.
Correct. Kubeflow is one of the things that we see customers doing a lot on EKS. Kubeflow, TensorFlow,
Okay.
EKS, and Mike mentioned it earlier, but we just did the pull request to kind of just add official support into the Kubeflow project.
Cool.
So
adding in documentation to show
adding
you how to do
documentation
it.
just to show how to do it, and
Very cool.
we're so that's another important project for us that we're going to be increasing our upstream contribution to.
That is really cool to see, and that project has been something that's really exciting for us from that perspective.
Probably worth a mention there. So there's this is yet another team at AWS working on container things. So there's a team at AWS that has been publishing deep learning. All right, is it AMI or is it AMI?
Ooh.
I'm gonna go down the AMI path here. So
You did as well, so we'll keep it there.
so that team has now started also releasing deep learning containers that are specific to this. So one of
cool.
the things that you can kind of assemble into your stack of pieces that you need to run your machine learning loads is like what container images you're using. And so we have some pre-assembled container images there that you can either build your own or you can start there, and those will have like the right CUDA, like what recommended CUDA drivers and
Cool.
So forth. So
Really gets you up and running. That's fantastic. So what else in the community are we actually working with? Like there's Kubernetes. We talked a little bit about Envoy. A lot of these are CNCF
Right.
projects. What other projects in the CNCF are we contributing to, working with, and doing things with?
I think the big one to call out here is etcd. One of the folks on the EKS team, Goho, is one of the etcd maintainers. Anyone who has run a Kubernetes cluster for any period of time starts to understand that a big part of the heavy lift is running etcd. So it's really important to us to both contribute upstream, just like we were talking before, like the philosophy of contributing upstream while you're actually running the service is, I would say, even especially true for etcd.
Okay.
And Gyoho gives also a great talk. I think he's doing one again at KubeCon this year.
Maybe we'll have to bring him into
etcd.
this.
Yeah, I think getting Gyoho on your
On that list
on
of
this list of
office hours?
upcoming
That'd be cool.
office hours would be amazing.
Okay. Cool. So what are we doing about this? So a lot of these projects, and we didn't kind of call this out yet, a lot of these projects that we're working with, besides maybe the etcd one, are they ending up under SIG AWS? And so can you talk a little bit about SIG AWS and what's going on there? Because there's some changes afoot as you're getting into the community.
Yeah.
Sure. So SIG AWS has historically been where AWS customers and developers can meet and help kind of push forward the state of AWS integration within Kubernetes. It's partnered by other cloud provider SIGs, and is really a good venue for kind of driving forward those features. Again, I believe it was about 2 years ago, the Kubernetes core team decided that they want to try to kind of pull some of the vendor-specific components out of the core and put them behind standard interfaces. And as part of that work, founded a new SIG Cloud Provider. SIG Cloud Provider kind of looks across all the cloud providers and defines these common APIs and interfaces, and then has started a project to kind of remove all of that. As part of that project, we've looked and said it's time to maybe reorganize our SIG structure a little bit.
Okay.
There's a lot of cloud providers that are currently involved in Kubernetes. There's others that are interested in getting involved in the community, and setting up a SIG is kind of there's a bit of overhead to it. You have to have leaders, and there's a whole process around actually building a SIG. So all of the cloud providers are being folded into SIG Cloud Provider, which will own that kind of integration from end to end and oversee all of the subgroups there. As part of that, SIG AWS, which is currently a SIG, is going to be converted into a working group, user group.
Okay.
A place where, a new concept within the Kubernetes community, but basically a place where people with common interests can kind of meet and push forward projects. It'll also own the code and repos and the infrastructure that is around all of kind of what is currently SIG AWS, and then just roll it up into cloud provider.
So something that we also haven't covered here is like, what does that whole organization actually expose to projects that get into these SIGs? Like, if we contribute a project, what does that actually mean from a management perspective? Are there tools that are actually added and like all that kind of stuff? Either one?
Want to take that, Bob?
Well, I mean, I think this is an area that the community overall, we're all trying to work together to find like what's the right balance between everything being included and being tested and things being separate. And so, like, in the evolution of the cloud provider, the all of the different NIs are all part of that. When a project goes into Kubernetes, you're essentially saying that Kubernetes overall as a project can't ship unless all the tests pass.
Okay.
So I think this is part of what the SIGs work on, is try to figure out like what is actually required for Kubernetes to pass those tests and then be used by all these different providers. So one of the general things that's happening here again is some of this code is moving out. When that code moves out of Kubernetes, it could move into a cloud provider specific repo. It could move as to a CNCF project. Like, there's different places that could go. The goal there is to have good decoupling, a standard interface, a clear path for the core of Kubernetes to be tested and reliable, but then also to let all of the different teams that have specific interests in working on like making their own trade-offs in terms of speed and new features and quality and performance, kind of make their own decisions a little bit decoupled from everybody else.
Oh, cool. So it gives a little bit of control back, and it won't block a release from going out if something isn't working as expected. Okay, cool. And how does that end up affecting the roadmap, especially for what we're doing on the EKS side of things? Does it affect the roadmap at all, or is it really just benefits us, I would assume?
I think overall we think this is going to let us go faster. You know, the fact that, for example, CNI, like we release our CNI code on cadence that's as fast as we can go with, you know, quality and security, and we're not actually tied into the Kubernetes into the core Kubernetes release in order to release that. Now, there could be new capabilities upstream that require changes to everyone in order to access that.
Okay.
And in those cases, you do have to like get the sync. But by decoupling these things, we think everybody can go faster.
And that's where we end up with KEPs?
No, I think KEPs are really more an overall attempt by the, again, this is when Kubernetes was really early. It's the Kubernetes Enhancement proposal. Yeah. So this is all about, for the community overall, transparency, good process. This is one of those things that happens. You have a small project growing really fast. things are maybe a little bit more casual in terms of how they work and how do things get built. And one of the things that's happened in the past has been you didn't actually know exactly where to go to find, for example, like what the discussion was going on about a certain feature. And so one of the like really, I think it's a comment on the evolving maturity of Kubernetes as a project is to standardize the process by which, we want to make a change to it. There has to be a document. There's a review process on the document, not just code going in. And so the KEP is the standard way in the community to make sure that all of that has been in public, transparent, reviewed. It's just good. It's just good practice and governance. And the KEP is the standard way to do it now.
And it's a great way to communicate engineering intent as well as testing practices and
Absolutely.
graduation criteria. There's a lot of really big benefits that the KEPs do give us from a just design thought process.
Right.
And they really define out like an owner, and like there's a full review process for it, and everything is like very cool.
And how does something graduate through the various stages of the Kubernetes release process? Like, what are the graduation criteria? Is what they call them.
Okay.
But it's a nice structure for just defining a feature and moving it all the way through to something that's really GA and production ready.
Gotcha. We didn't actually talk about any of that versioning structure. You called out that our CSI drivers are in the alpha and beta state right now. What does that actually mean in terms of like how does the KEP work with that? Is that what you're talking about, the graduation period?
So yeah, when a feature is added to Kubernetes, there's three major phases for that feature. There's alpha, which is kind of brand new functionality that maybe not quite as stable as you'd like it or subject to change. Beta is kind of the next stage of that, where you build more confidence and things should be changing less frequently. There should be fewer backwards incompatible changes. And then GA, where it's public and production ready, and it's basically frozen at that point. You can bug fix it, you can add new features to it, but you can't break any backwards compatibility. Those APIs are fairly well set. Gotcha. So our projects do move through that process, especially things like CSI that are implementing a standard interface. And I guess it's kind of a measure of stability on our side as well, how comfortable we are with kind of the final state of that.
Very cool.
This is also why, as a kind of general principle, we haven't wanted to support alpha features as part of the EKS service, because we don't want to be encouraging customers to take on API that might change and break their applications when we actually take the next step.
In an alpha stage, it's really not uncommon for that to happen.
Yeah. That's the expectations. You have
can
to
just
make the first
change
step to get it right.
Yep.
And so you're going to have to make a change to get it right. And that's just part of the process.
Yeah, alpha's all about learning.
Yeah.
That's really cool. Well, thank you both, Bob and Mike, for
Thank you
joining
very
us.
much.
This has been a fantastic hour. Thanks for joining us. This is actually going to be going on every Thursday at noon Pacific. So come back next week. I think we're talking about building images with Nathan Peck, if I recall correctly. See you next Thursday.
All right. Thanks very much.
Thank you.
Thank you.